Over to you, Dr. Shinji.
Thank you, sir. Thanks a lot. It's been an honor to speak in a flagship event of IEEE Kerala Section, and thanks for the entire organizing committee as well as the participants and all the people who are currently viewing online. I hope I'm audible. If not, please message me. Shall I share my screen?
Yes, sir.
Yes, sir. Yes, sir.
So we are here to discuss about the deep learning techniques and time series forecasting. And these are two key terms which are yet to, in my personal opinion, from the industry perspective, it's two techniques which are yet to fuse very well together. But there are a lot of developments recently, especially in last 2-3 years, starting from the evolution of transformers and all. So we'll be discussing on how the time series forecasting was approached in the earlier techniques, and started from the very basic of seeing how it was approached using ARIMA and all, then move to how can we solve the same problem with machine learning techniques, and what is the difference, and what are the advantages, and those are the introduction session. Then we'll move on to the deep learning part, starting from neural network, how to adapt or include the recurrent neural network for time series, then to have the components like attention, self-attention, etc., and to finally build a network which can predict or forecast the time series. So that is the essence. I don't want to lag a lot of things about content. We'll see. So starting from time series, assume that, so we all know that what is a time series. It's a sequence of information, right? When we say that it's a sequence of information, it is indexed in time order. It is a time-stamped entities or a time temporal data. That is what the terms which we used to call a time series. The examples are in stock market, in the demand forecasting, the prices, everywhere, even the signals, we have the time component. So everything has a time component in the x-axis will become the time series. And how to analyze the time series, we have a different mechanisms over long time, because this has been researched over centuries, I would say, because people are always curious about what happens in future. So that is the essence of analyzing time series. So it's been researched over centuries. That is what I would say. From a time series, we have to see the trend, how the trend is evolving over years. So you can see, I hope you guys can see the observed part, where time series of a furniture sales is been displayed here, and x-axis is the date. So from 2014 to 2015, this is the pattern. Then 15 to 16, this is the pattern. Likewise, we have plotted the time series. Now, from the time series, what is a trend? This is something which is generated by the ARIMA package, so that it is not, I won't say that it is pretty accurate, but it gives the essence of how the trend is, how the overall or the smooth and version of the demand. Then there is a seasonality. Seasonality is actually the repeating pattern. Every February there is a dip. In 2015 February, 2016 February. So every February there is a dip. Every November, December, probably due to Black Friday sales or something like that, there is a hike in sales. So likewise, there will be a repeating patterns which can be yearly, weekly, month, daily, etc. Or even an hourly. That is very rare, but still. So this is about the seasonality component, and then there are some components which we find it difficult to model, because those components will be induced by some sort of random shock or some other external influencing parameters. So when we say that sales of a furniture, it can have a lot of influences. Those are the external parameters. Other than that, there will be some residuals which we cannot model. So many things are additional components to the entire time series. If we decompose it like this, it is easy to solve, but unfortunately we are not sure about the residuals and the other additional parameters. So we need to invest a lot of time and effort in curating the data, and all. We'll come to that. So we defined what is a time series, what is trend, seasonality, etc. So once it is defined, then what are the types? There are two types: simple, univariate and multivariate. It's all known to everyone. Single time dependent variable. When we say that univariate, there is only a single time dependent variable. Consider the example here. We have temperature and we have the time, which is the x-axis, and y-axis we have temperature, and this is the only variable for which we are supposed to forecast. So forecast at yt, or probably at 11 a.m. would be A is our weight, then temperature at 10 a.m. plus B. So this is the simple. I mean, this is not the way, but this is how we can understand. Now the next part is we have a series of variables, or a list of variables. All are time dependent variables, and we want to predict temperature, not only considering the historic temperature or the previous temperatures. We want to consider the other factors like cloud cover, dew point, etc. This is a classical example. And right now we have 5 variables, and from the 5 historical variables, like what is the temperature, cloud cover, dew point, etc. at 8 a.m., we want to predict what will happen at 9 a.m. So that is how we are analyzing different types of time series. And I won't say that these are the key features. When we discuss about how to improve the forecasting and all, a lot of other factors need to be considered that we will discuss. So classically what happens is we have the time series as displayed here, and then we are supposed to forecast. Assume that it goes like this, and this is at 10 a.m. and we want to predict what happens at 11 a.m. Many things has to be considered when predicting 11 a.m. And we all know that. But assume that we take what happens between 9 a.m. and 10 a.m., which is our window. Then we are predicting 9 a.m. So we are fixing a window and then predicting 9 a.m. So this is happening. And when we say that we are fixing a window, that is our lag values. So here, assume that we take a data point in every 15 minutes. So that there are 4 data points. These 4 data points will become our xt minus 4, xt minus 3, xt minus 2, and xt minus 1. And then we are predicting xt. Xt is our time at 11 a.m. If we define the lag values, now what were the approaches in predicting xt from the xt minus 1, xt minus 2, xt minus 3, xt minus 4? One was moving average, where we assume that there is a time series of stationary nature, and we have a mean, and we have some random shock event based noise, white noise, we call it as white noise, is being propagated, and we are trying to model the white noise component for each historic events in our lag period. So as we said that we considered 4 events in our lag period, which happened at 9:15, 9:30, 9:45, and 10 a.m. These are the 4 events. And what were the random shock happened in those 4 events, and using that the linear combination of those random shock plus the mu or the average or mean of the time series across the entire data can be applied, uh, which has a relevance when the time series is stationary. And so it's a linear combination of white noise. White noise is the residual error or the error. Since we cannot model actual noise because it is unobservable, what happens is we will use the previous forecasting error as a noise component, and that noise is taken and model it. So this is the basic of moving average. Then when we come to autoregressive model, it's straightforward. It is a linear combination of all these 4 values. So it's a into xt minus 1 plus b into xt minus 2 plus c into xt minus 3 plus d into xt minus 4 plus we will have another component for handling the noise, where probably e into the noise or epsilon. And in this case, we consider only individual random noise without considering the sequence of noise which happened over last lag events. That is the specialty of autoregressive. Then comes the ARMA model, where we will incorporate the both type of modeling together in a single platform, so that it will also model the sequence of noise, and it will also model the sequence of historical values or the lag values. Then comes the ARIMA, where one I is added. What happens in ARIMA is like we have a tendency to model based on the mean and also on the noise part, but we generally don't know whether the time series is going like this. If it is going like this, then the mean is consistently changing over period of time. Assume that we have the data points in x-axis, and if we take mean values, see at this particular point the mean is this, and at this particular time point the entire mean of the data set will become this. So mean will change over time. So that is where it is not stationary. How can we make it stationary? We can create a difference, and difference between the immediate 2 values, xt and xt minus 1. We will create another series where xt minus 1, xt minus xt minus 1 will be the values. So that difference to time series is used in ARIMA to make it stationary. And then when we say that difference, there are orders of difference, how many differences which we can make. So D is the order of differencing. And we discussed about the continuously repeating pattern or pattern in a short period of time. So that is the seasonality. To handle the seasonality, we can apply difference with assumption that we are differentiating between 7 minutes. 7 times. So that is how things being done. This is another concept of profit which is developed by Facebook. It's available in library, anybody can use it. But what essentially they are doing is they are handling the multiple seasonalities, and when they handle the multiple seasonalities, they take the logistic curve, logistic or linear growth, or the average of the demand across the entire period to have the smooth and trend. Then there is a component for modeling that. Along with that, what happens is They also model the seasonality. As see, every September, November, there is a high demand. So the seasonality is also be considered. Yearly seasonality is modeled using Fourier, and then the others are actually modeled using dummy variables. This is something which is proprietary of Facebook, which is available. We can use it. Is one of the approach. Then how we will approach the same problem in a machine learning domain. So in a machine learning domain, this similarly we have the lag values of the lag period, and from that input period we want to predict the output value. So we will create a features out of this input period, and then we will predict the output period. And we have different techniques like random forest, SVR, feed forward, SG-boost, and many ways of extracting features is there that we will discuss once we discuss on the application side, which happens in the industry. Then comes the neural network, which is the topic of interest. So when it comes to neural network, what happens is we have a data like this, and these are the historic data of movies which I personally liked, and there is Mary's rating and John's rating in x-axis and y-axis. Blue dots represent the movies which I liked, and the circle dots represent the movies which I didn't like. And I want to find whether I want to build a model so that it can effectively classify whether the movies which I like or not based on the rating of Mary and John. So if that is the case, we need two separate lines in effectively. With the neural network, we can have one neural network, one perceptron modeling this one and the other perceptron modeling this second one. And then we'll have the combination. We will not be explicitly asking it to learn, but this is the basic. We all know that. I don't want to spend a lot of time. But when it comes to deep learning concept, what is the difference? Here, if we add lot of neurons as per the universal approximation theorem, we can approximate any continuous function. So as long as function is continuous, any function can be approximated by increasing the number of neurons in a single layer itself. Why we need more layers? One thing is we don't have a mechanism to ask this particular neuron to learn this line and this particular neuron to learn this line. So that is one problem. So when the data becomes more complex, adding more neurons will not solve the problems, may not solve the problems because we cannot efficiently learn it. Then what can be done? We will hierarchically learn the complex functions. We will learn the first function, which is a straight line. Then we will combine a couple of straight lines to a nonlinear function. Then we will hierarchically combine it to another complex function. So we can have more layers, which will solve this problem. This is called deep learning, or this creates the depth in learning. We are hierarchically learning the complex functions. That is the essence of deep learning. If we assume that that is the essence of deep learning, then it works very well, especially with the data like text and images, because there the function is more complex. And so we know that the input signal or the lag period is input when it comes to a time series forecasting, and we want to find develop a neural network for that, and we need depth to learn the complex functions. Once all these platform is set, the next platform is actually to understand how to efficiently learn it. There are two relevant components which have to be discussed. I don't want to spend too much of time. When we learn a feed-forward network or the conventional neural network, there are dense connections happening. So all the input neurons are connected to one layer, and all the intermediate neurons are connected to the second layer, and then to the output layer. if we learn like this, the codependency among each other will increase. Like all the 5 values are expected in this case, and we have a tendency to memorize, or the network has a tendency to memorize exactly data as it is. That is actually a difficult problem. When it memorizes the data exactly as it is, then it ends up in orphiting. How to avoid that? We will randomly zero out or ignore some neurons in iterations. So every layer, every sample, every iteration, we will randomly select a set of neurons and zero it out so that we will not use it. If we use 0.4 or 40% dropout, 2 out of 5 neurons will be zeroed out. That they will be ignored in that iteration or epoch. This will, in a sense, try to induce a small regularization. Then the second concept is normalization. Every uh, when we increase the layers in deep learning, we had to change the activation to handle some problem of vanishing gradient and all. I don't want to get into the depth behind that. So that problem essentially ended up in increasing the values as it moves from here to here to here. When the values are increased, we are using the stochastic gradient descent or the gradient descent, variance of gradient descents like Adam and to learn the weights. In such cases, what happens? Exploding gradient is another term, and the changes in gradient over iterations or epoch will be very small, and the values generated are huge. So the cost function is huge. It will need a lot of iterations to finally converge. So what we can do is we can normalize data coming out of each layer in layer itself. That will save a lot of time. That is the concept behind batch normalizations. Once these concepts are set, we are good to analyze the time series. And then when it comes to the time series, we have a sequence of information, and a sequence of information is actually some sort of a recurrent function. So that we need a recurrent neural network. What is the essence of recurrent neural network? It has a feedback network. We give x t minus 1, then the output of x or the xt minus 2. Sorry for the notations. I don't have a whiteboard. Please bear with me. And the hidden state h t minus 2 and xt minus 1 is the input. The hidden state h t minus 2 is the feedback, and then the output is generated. That is what happens in RNN. When it comes to LSTM, here the hidden state is fed to the next. That is the essence. When it comes to LSTM, we have a memory where we store informations, and we have information coming out of hidden states. And first thing which we'll do is, using the previous hidden state and the next hidden state, we'll forget irrelevant information in the memory. That is happened here. And then we will try to, sorry for the noise. Then we'll try to identify what is the important information from the input and previous hidden state to be stored in the memory. That is happened here. Once both are done, the next part is to recognize what, based on what we have in memory, what the input is, what should be our next hidden state. That is the essence of LSTM. And when it comes to variants, there are bidirectional, there are GRUs and all. So this is the basic. Now we understand that if a sequence of information is given one after the other, that order is captured, some of the information from the time series is stored in the memory, and then after analyzing the time series, we are able to make a prediction using a simple LSTM model. Good. But that is a way of predicting one value at a time. What if we want to predict next 7 days of information? Assume that we take last 7 days of price for a commodity like soap, and we want to predict the price for the same commodity next 1 week. What is the process? So here we take x1, x2, x3, other 7 days of information, and then we have the LSTMs or GRUs, and then that step is called as encoder. Then the next step is called decoder, and after the encoder we create a vector information, a numbers information, and that vector information is actually fed to the GRE for the predictions. And how can I say that without both? So the encoded state is fed to GRU along with the last XM. That will initiate the first output or the next day's prediction. Then that prediction is given to the given as input to GRU for predicting the second days. Likewise, we will predict the next 7 days continuously. It's a very elementary idea, concept. Okay, sorry. Here we take input time series and predicts the continuous predictions. 7 days of information is taken one by one in a GRU, and then 7 days are predicted one by one in another GRU. But will that address our problem? We will have a lot of seasonality component and other features has to be incorporated. That's the reason why we have a multiple set of features are combined together when we are giving the information to a single GRE component, and then we predict it. Then we said that 7 days of information are continuously given, and we generate the values at H1, H2, H3, H4. Which is the hidden state output coming out of GRU at each instant of time. After giving the data of a Monday, we will get hidden state of Monday. Then we will give the information of Tuesday to generate the hidden state of Tuesday. Then in attention framework, what happens is we will take the input in generating the next Monday's prediction, which is the S0, and that S0 along with the H1, H2, H3 and H4 will be combined together, and then we will understand which of the H1 has to be given priority when we are going to predict this particular Y1. The relevance is we have a set of words in a sentence and we are trying to translate it. I want to translate I love my country. So I has to be translated to the German or whatever language it is. So I is the input which I have to focus. So which data point in the input has to be focused. So when we are predicting a highly seasonal weekly data, we have Monday a demand, Tuesday and another pattern of demand, etc. When we are predicting next Monday's demand, we want to look into what happened in the last Monday to predict the next Monday. So that is where attention become very relevant in time series. When there are highly seasonal data and we are having the window of one single season as input and we are predicting the entire season as output in a sequence to sequence prediction. Then what is the next way of improving the attention? We saw that the recurrent neural network is been quite some time. It is iterating the data over what is predicted in the next previous time. So under under that framework, the problem is the length of a network is similar to the length of time series in the input, because for generating xt we need ht minus 1. So assume that we have 100 length time series data in input. We need 100 length neural network to generate the final time series output. For the encoder alone, the same iteration has to be repeated in the decoder alone. So the parallel computation, which is the trend of this generation with the GPU and all, cannot happen. There are some challenges in other aspects as well, and the effective propagation of the information in back propagation algorithm will not happen in the initial period. It's not a vanishing gradient, but when still the depth is getting increased to a large extent, right? That is the challenge. So what people does is they generated a multi-head attention over flattened time series. When I say that flattened time series, it doesn't have a recurrent nature. Instead, the entire time series is flattened as a single vector, and each vector will be given an embedding. And embedding is the word to vector, whatever embedding which you can mention. And after that particular embedding, then we are supposed to give attention to the relevant information from the input data. How can we create attention to the relevant information from the input series? So for that, what we can do is we can create a queue, K and P. The Q is query, keys are the K is key, and then V is the values. We assume that I have two kids. One is my daughter and one is my son. So if I give 3 sweets to daughter, then the 3 sweets to my son, what happens is they need it to be equal. That 3 should be same for both, right? So one, at time t, I'll give 3 seats to my daughter. Then I have to remember I gave seats to my daughter. Then I have to give it to my son, and 3 was the number. So query how many sweets, and key assume that we are trying to map it as sweets, and then value there are 1, 2, 3, 4, 5. We want to find the exact value which has to be given. This is a very crude, very unprofessional way of explaining it, but still helps in understanding. From the input itself, from the data of input itself, I am trying to find what is the query, what is the key, what is the value with a simple projection. So X is being projected to Q, X is being projected to key, X is being projected to values in a philosophical way. So from the input itself, we can find the query, keys, and value. And then query and keys used to find the weight for values, and that weight will be multiplied over the values to give importance to the part of information inside the values. So that is the essence of self-attention, which is the focus, which should be our focus. Then this is the scaled dot product attention, and that is being combined with multiple layers. There is a linear transformation layer for V like this, and then we have multiple attention layers, and finally we will be concatenating it and generating the multi-headed attention. So given input, we will have multiple layers of attention to finally generate the output. And the most important point here you want to remember is that for generating data at x t, we will have prediction of yt minus 1 available. That yt minus 1 is given as output encoding for for the encoder layer. Why? Because I need to remember that earlier for my daughter, I have given 3 sweets. That was my earlier output. That information will be given as output encoding, and from there it will create an attention for information coming from the encoder layer to which the focus will twist on. Then we will have a prediction. So that is the self attention, and this is a deep network. I don't know. Then we have another mechanism of solving it using convolutional network. Uh, I in practice we have a convolution goes like this. We will apply convolution filters across images or data, then we'll merge it to single node. Then similarly, we will have another convolution filter, merge it to node, and then they will be combined. So, but in time series forecasting, what happens is we are dealing with time data. So when we want to predict xt plus 1, uh, after seeing xt, so we don't know what happens in future. We have seen data only up to xt. Then we want to predict xt plus 1. What happens is this information cannot be carried out. So this sort of the usual convolution cannot be applied. So there is a causal convolution which will always be happen in this manner. And you can see the animation to help me. And this is very short video to explain the concept. This is how we are generating the time series in our time. First, we will combine the convolutions to reach the output. Then we will combine the next output. Next, take the next input to combine it to generate the output. This is the CNN way of doing it. We will summarize it. We have seen the neural network. We have seen the attention, dropout, batch normalization, conceptually what it is without digging into the details. Then we have seen self-attention, how that is being relevant, and now how to evaluate the models. One is the mean squared error, mean absolute error, the convolution, the conventional evaluation techniques in a regression domain. Next is a mean absolute percentage error. Assume that I am predicting the price or a demand for a commodity over time. Then the price value has output in range of 1 to 100. And I have predicted another commodity price where the price range is between 1000 to 2000. If 1000 is predicted to 2000, that is a huge problem. But if 1000 is predicted to 1100, that is a small problem. Similarly, in the other, for the first commodity, the price was 100. If we predicted 200, that is a larger problem, right? So the exact difference value may not capture the impact of error. For that, we will use MAPE, a percentage error. And for cross validations, we can use nested cross validation, pretty simple. We will take data up to xt and we will predict it for next 1 week. Assume that we are dealing with the daily data. We will take data up to March of 2017 and predict for April 2017. Then train till April 2017 and predict for May. Till May 2017 and predict for June. Likewise, that is the way we have to do cross validation to get it evaluated properly, and this should cover the seasonality behavior. One complete season of the entire time series has to be covered for a proper evaluation. And finally, when it comes to industrial use case development, how can we develop the use cases? We'll start from identifying the data sources. Then we will migrate the data. We'll do the proper EDA part and then do the feature engineering, model selection, model evaluation, and finally we will release the model. That is the way which happens in industry. So identifying the data sources, identifying the problem. Assume that one customer came to me with the problem of finding the right price. They want to set the right price. For finding the price, that is a tricky job. We cannot directly forecast the price because that is having a huge revenue impact. That may create a lot of problems if we predict it wrongly. So what demand, we can predict the supply, etc. So likewise, we will predict the child components from which we can derive price out of it. That is one way of doing it, or we can straight away predict the price. That depends on the problem to problem. What is the exact problem that we will identify? Then which variable are we targeting to forecast? That is very relevant. That we will identify, and then we will extract features, do the EDA and all. So when we have identified the exact problem and extract exact features, then the challenge is to analyze correlations, whether the variable which we identified as input has an impact to the output, whether the inputs are being correlated between each others. So likewise of correlation analysis will be done to extract the relevant information or relevant input parameters. Then we will have a missing values in the data. So we will treat the missing values, and we will have outlier detection to handle the outliers in the data. These are the conventional data science. In specific to time series domain, we will mostly be using nearest neighbors or interpolate or maybe Kalman filter, etc. These are the three different ways in which we handle missing data in time series. And Prophet, like the algorithms like Prophet, doesn't require missing value treatment, and when we model it in regression also, we can handle the missing values in different ways. So this is not a necessary step, but this is a step for some algorithms. Outlier anyway has to be done. There may be some certain unmodelable event triggered information in the database, can also be a wrong information. So that will happen. Then we have a time series. Assume we have a univariate time series and single variable, and from which we have to extract the data. We want to capture the seasonality information. For capturing the seasonality, we can either pass day of a week so that it will capture the weekly seasonality, and whether it has to be passed or not, that decision will come after analyzing whether there is a seasonality component incorporated inside the data. So that will be the analysis done to determine whether to include this seasonality. And based on what level of seasonality, we will include these features. And then the second is to capture the trend. An order number would be enough because a trend can be increasing over time or decreasing over time. Then the features, other features which we will be extracting from the sliding input window or the lag values can be Fourier coefficients or wavelet coefficients when we are dealing with signals kind of data in speech analysis and all. Then crossing points, how many times the time series is crossing the mean of the time series. Then entropy, spikiness, how many, what is the strength of spikes in the window, input window, the mean, median, mode, etc. So there are many ways in extracting different features. And once the features is extracted, we can do a regular shallow learning approach, which is the conventional approach. For deep learning, there is something which I wanted to convey as a take home. Deep learning, we can give the sequence input. So we want to predict what happens at this particular point of time by seeing the entire last 1 week data. This is 1 week data, and we want to know what happens in next Monday. And in that case, this sequence data will become input, encoded of date time features, which is what is been discussed in seasonality, comes in this layer. Then categorical data, probably some other data will be coming into picture. Similar to that, we can have a social media sentiments score, videos of consumers, reviews of consumers, etc. When we are defining the price of a commodity or demand of a commodity. So lot of other weather like information, lot of other variables can also be incorporated. Either we can replicate it across the time series, or we can have a dense layer to which the both information can be given, and then we can merge it in the hidden layer to generate the output. So there are different techniques in which we can handle these informations. And we'll design a network for that. And the next part is whether to use LSTM, GRU, CNN. So those decisions have a huge impact from another parameter. Probably I will discuss in the next slide. Yeah, this is the topic. So that is like if we have 500K revenue, we are expecting a 500K profit after implementing the current time series forecast approach. Then if the investment is 250K, then our profit is 250K. Here, if we use a random forest or a time ARIMA, we can implement it with 100K and say the improvement which we lose is actually 50K, but overall profit is 350K. Which will we choose? Algorithm 2. Likewise, based on a lot of revenue impact, we will choose the right model, and then we will finally set up the model. So in conclusion, we have statistical learning started with capturing the seasonality, trend, etc. Then incorporate that in the ARIMA model, profit, etc. Then we moved on to the machine learning phase where people were started developing with random forest, SVM, etc. By handcrafting the features like what we have seen here, along with the lag values. Then deep learning came into picture where the sequence or slice of window as such is passed, and deep learning is asked to learn which of these important information has to be learned from that lag values. That is what happens with deep learning, and where the attention has to be given, how seasonalities can be induced by attention, how the trend can be captured, etc. Then we have to take a decision of revenue and cost. Finally, the reliability versus error rate. When we have developed the product and it is been put into production, it will have an impact. So, where there is a trade-off between reliability and error rate, and everything has to be automated so that it will run for long. So this is my take on time series in industry perspective. And sorry if I took 5 more minutes. That's all from my end.
Yes, sir. Thank you, sir. Thank you for those enlightening words. I now call upon Dr. Anjana P. Das, who works as an AI specialist at Tata Elxsi, to deliver the vote of thanks. Over to you, ma'am.
Okay, a very good morning to all. I feel honored to say some out of thanks to Dr. Shiju SS. It's such a wonderful talk, and powerfully he explained the various aspects of time series forecasting modeling. Since we all of us are experiencing so many problems in our professional life to solve such problems, he presented a systematic approach of handling the time series data and all. Thank you very much on the behalf of the RAICS team and the whole IEEE Kerala chapter community. I would like to thank Dr. Shiju SS for spending his valuable time with us. Thank you. Thank you all.
Thank you, ma'am. We at IEEE Kerala Section would now like to present Dr. Shiju SS, Architect, AI and Automation in Litmus 7 Systems Consulting Limited, Cochin, with a memento as a token of gratitude.
Thank you. it was a very long session, one and a half hour session. I tried to limit it to 45 minutes. I couldn't convey the entire essence. That is something which I have in my mind. But I hope I could reach some thought. I could induce some thoughts in everyone's mind. And with that, I'm signing off. Thank you.
Yes, sir. Thank you, sir. And with this, we mark the end of the second keynote session of IEEE RAICS 2020. Now, we shall move on to the third keynote session, for which I invite Dr. Amarnath Raja, who is the Chair of Society on Social Implications of Technology of IEEE Kerala Section and Executive Chairman at TINAP, to deliver the welcome address and introduce Mr. Paras Lumba and Mr. Jaydeep Bansal, who are the keynote speakers for the third keynote session of IEEE RAICS 2020. Over to you, sir.
Good morning, and thank you so much. I see Paras and Jaydeep are there on the participants list, and they are ready to give a wonderful talk. It's my duty here just to introduce both of them. Actually, their own talk will be a lot more introduction than what I can give in this brief time, and let me keep it as small as possible. Paras is an electrical engineer, and he was working with National Instruments when he got an opportunity to visit Antarctica. With that inspiration, and he started something called the Global Himalayan Expedition. This is a unique social enterprise, which many people in Kerala could emulate. They leverage tourism to help the underprivileged people in the Himalayas. So here we are in another tourist area, and I'm sure we can emulate them in some way. Coming on to Jaydeep, he is an IITian from IIT Bombay, and I think 2010 batch something. He was working in Procter & Gamble when we first met him in Kathmandu in 2015. Later on, I understand he resigned his position and joined Paras in his global Himalayan expedition. Both of them, both of their excellent work they were doing got into international limelight with a documentary of their work by BBC. And we had watched this documentary and we were very much impressed with them. That we invited, when there was a disaster in Nepal and we were going there, we invited them to come and help us in this wonderful, beautiful project that we did there. Since then, this wonderful group have impressed great people like Bill Gates, Warren Buffett, and made many presentations at international forums, including Davos, World Economic Forum, and many other places. How are they associated with IEEE? So in 2009, 2010, IEEE PES had formed a group called Community Solutions Initiative. You might have heard of the names of Ray Larson, Robin Podmore, and many others who had formed this, Mike Wilson. This is now called the Smart Villages Initiative. GHE was associated with them in many of the projects in India. And in particular for us, after the 2015 Nepal earthquake, when Kerala section was looking at ways to support Nepal section in their relief efforts, we contacted Paras and Jaydeep, and without any hesitation, they came to help us. Within a week of the earthquake, Jayakrishnan and I met them in Kathmandu, Nepal, and they provided their full support throughout the project, especially during the initial survey and project formulation time, when we did not know anything about doing work in the mountains. In spite of what they have achieved, I have not met so nice people. When we were planning to do the survey in the area in high mountains, And we were planning, like, let us say, 1 month later or so. And then Paras told me, shall I go today and complete the survey? Totally taken aback. And next day he left for the high hills, and then he did this complete beautiful survey result that he came out with it. Later on only I trekked the same route for the actual project, and it took me 2 to 3 days just to reach the place itself. I should say I'm humbled looking at their achievements and looking forward to hear their talk. Welcome to both of you to Kerala and IEEE section, Paras and Jaideep. Looking forward to listening to your talk. Thank you.
Thank you so much, Amanat sir. It's an honor and an equal pleasure to be part of the IEEE Kerala conference. And it's been a very difficult year for us because of the COVID reasons. We couldn't go up into the mountains this year. But whatever we could do virtually, we still, our hands are tingling to see when the thing goes over and we are up in the mountains back again, doing what we like doing best, is climbing mountains and electrifying villages. Without taking any much of time, like my colleague Jaideep, to talk about our initiative, what we have been doing, how we have been doing this, and what is the future holds for us in terms of our initiative. So over to you, Jaideep.
You're muted, Jaideep.
Yes. Thank you so much, Paras, and thank you so much, Amanat sir, for such a warm welcome and for your gracious remarks on the work that we are doing at GHE. A very good morning to all of you who have tuned in to the presentation and the webinar for the IEEE conference. And over the next 35 to 40 minutes, we'll take you from Kerala all the way to the mountains in the Himalayas and hopefully share some of the work that we are doing in bringing energy access and holistic development to the remote communities and create some inspiration as well as opportunities for collaboration through this presentation. GHE was started in 2013 by Paras with the vision and mission of bringing access to development to the remotest communities of the world living in the mountain areas of India. And the way that we have been doing that is by leveraging technology, by bringing in sustainable development, because we feel technology and using innovative ways of technology can really bridge the gap and really advance these communities that have been left behind due to their geographical remoteness. Our vision is to create carbon neutral villages. And how do we do that? We do that by bringing in access to solar energy, by creating zero waste to landfill by ensuring waste segregation, carbon removal by installing solar water heaters, greenhouses, as well as clean cook stoves in these areas, and in a way create a circular economy where the community is benefiting and uplifting themselves out of poverty through the various impact initiatives. And in the process, we are able to touch upon 8 of the UN Sustainable Development Goals in the remotest communities of the world. And the fact is that if we want to achieve the UN SDG goals by 2030, you cannot leave anyone behind. Everyone has to come together. Everyone has to be brought onto this journey of advancement. And our impact portfolio ranges from solar electrification of villages to providing digital education via experiential learning, setting up solar health access for these communities. And this has been very much in need in a post-COVID world. Carbon removal by replacing diesel generators with solar power and through clean cook stoves. And then ultimately, all of these impact initiatives cannot work in silos. You need livelihood development. And that is where we are working with the communities on creating opportunities for livelihood and income generation through homestays and through solar powered homestays. And all of this is only being backed by the growth engine, which is the skill development and capacity development, which serves as the bedrock. Because if you do not train and empower the communities, if you do not develop the skills in them, all these initiatives cannot be sustained. So that's the bedrock of how we are sort of really scaling up the work that we are doing. We are looking at transforming communities from pre-industrial revolution technology to a fourth industrial revolution technology, where the communities are now producing and consuming their own energy. I mean, think of it. All of us are dependent on a big grid infrastructure for the energy that we use to power up our laptops, to power up the lights and the equipments in our houses. But these communities in the remote Himalayas are able to produce and consume their own energy. And that is really the future of electricity, where you're not dependent on a big grid infrastructure that is susceptible to failures, that is susceptible to virus attacks, but you're able to create nanogrid, microgrid solutions which are much more sustainable and which are much more efficient. Globally, there are still more than 800 million people that are living in darkness. And these communities are living in some of the most beautiful and remote locations of the planet Earth. When you look at this picture of this village in Himalayas, the immediate thought that comes to your mind is just, wow, clean air, fresh water. Everyone wants to live in such a paradise. But what happens when the sun goes down? The communities end up using kerosene lamps for their lighting needs, which produces a lot of toxic fumes, harmful to the young and the elderly. What is happening is that due to these lack of basic facilities and due to lack of education and livelihood, the communities, the youth, they do not want to stay in the villages. I mean, think of it. Put yourself in their shoes. You are in a position in a remote village where there is no road, there is no connectivity, there is no mobile connectivity, there is no access to electricity. The immediate compelling need that comes is to provide good education, do good healthcare to your family, and then as a result, the communities end up migrating to the towns, leaving behind a culture and heritage that is centuries old, and resulting in villages that are now vacant. Now, what happens is our model focuses on bringing in development to the communities. So instead of getting people to migrate to the development, how can we bring development through smarter technology to these communities so that they don't have to migrate? And our operations are very simplified. We identify villages, our local entrepreneurs go survey the communities, mobilize the communities. We then seek partnerships like we have done with IEEE Smart Village. And then once we bring in our partners and then we get the funds in, we then bring solar electrification to these villages. But it is not just a parachute approach where you just drop into these villages and you say, hey, we are going to give you electricity. It has to be a proper process. There has to be a community buy-in and there has to be a pull from the community. And so it's important to mobilize the villagers where we talk to the community, we share with them the model of impact. We share with them what kind of technology are they getting? Are the villagers convinced? Are they willing to sort of buy into this development model that GHE and our partners propose? And it starts with the community opening a bank account, a community account which will be used for the maintenance and the scaling up of these solar grids. Because you can put in the infrastructure, but if there is no maintenance, if you do not develop the capacity of the local youth in these areas to maintain these solar grids, after 1 year, they'll stop working. And so these community accounts ensure that every household puts in 100 to 150 rupees a month into this account. And the money keeps accumulating, and think of it as a way to service the grids via AMC model. So that's something that is being used in big industries that we have tailor-made and applied to these villages. Till date, we have been able to impact more than 131 villages and 60,000 lives that now have access to clean and renewable energy. And in the process, we have been able to offset more than 35,000 tons of carbon emissions. I mean, the picture that you see in this village, it's a centuries old, more than like 1,000-year-old monastery, which was electrified in just 3 days by the IEEE Smart Village team. And that is really the power of bringing in technology. And that is really how you can bring in sustainable development and leave no one behind. And this is how simple it is. Before and after, in just 2 days. This was the first village that Amarnath sir mentioned about that we electrified, a 1,100-year-old village based on the wooden Buddha statues that were found in this village. Now think of the rich culture and heritage that resides here, and think that without access to development, this heritage will not exist. So by bringing in access through energy and the education, we have now seen a reverse migration where people who left behind the villages to the towns are now coming back to the villages because they can see that the villages are becoming smarter. They can see development coming to the villages. And this is the visible impact from kerosene lamps to transition to the fourth industrial technology, LED lights powered by solar energy in each and every room. How do people react when they see light for the first time? Well, the reactions are priceless. People start dancing, they start looking at the light bulb, and some of them even start praying before it. That is how much it means to them. That is how much it means to provide access to energy to people who have been still living in darkness. It's not just about the Himalayas, but we are also operating in the northeast part of India, in the Garo hills of Meghalaya. So from the mountains all the way to the jungles of Meghalaya. And what is really inspiring is in this picture, if you see on the left-hand side, there is a woman who's leading this group of people. And that woman, her name is Gurmeet Angmo. She is a Ladakhi woman trained by us as a solar engineer who has been working with GHE for the past 3 years. She took the initiative and the step to come with our team all the way to Meghalaya, and she led the group of engineers there to bring light as part of the pilot projects. And so that's where I talk about the capacity development. It's so important to invest in the communities to develop their capacities because they can do wonders. I mean, a Ladakhi woman coming all the way to the Garo Hills, remote Garo Hills in Meghalaya, she does not know their language, yet she was able to, train the people in how to set up the panels, how to set up the grids. And, in just again, in a short span of her 5 days being there, she was able to electrify more than 3 villages. That's truly the power of human will. Now, the technology is really simple. It's a DC microgrid technology. The solar panels go on the roof of the houses, the batteries go inside, and with a charge controller, which is the heart of the system, we then do the wiring of the entire houses. Sometimes we cluster a couple of houses to put up a bigger grid. Sometimes if these are isolated houses, then we put an individual size grid. And this is much more than a home lighting system. This is lights. You can run LED lights, you can run television, you can run fans. So it's basically providing overall electricity to these households in the villages. And why DC? It's easier to install, it's shockproof, and it creates a much better output with much better efficiency for the entire ecosystem, because the entire ecosystem of electronics that we set up is DC in nature. It's just much better and much efficient that way. And then it's about, like we mentioned, empowering the communities. So these are examples of the Garo Hills in Meghalaya, where before even electrifying villages, we conducted workshops for the youth to be trained as solar engineers, and for the women also to be trained as solar engineers for more than 3 months before we started doing our pilots. And now, as we speak, during COVID times, we could not go there, but the villages are being electrified as we speak. And this is a partnership. Not all of the work that we do, we try to engage the local government. And so in partnership with the Chief Minister's Career Guidance Scheme, we train more than 30 youth as solar engineers in partnership with the district administration as well. Now, from the communities, like we said, the community has to buy in. And this is a great example, which you can see that 100% of the community wants to replace their diesel generators to bring in solar energy and to make their villages carbon neutral. I mean, the Prime Minister keeps talking about carbon neutrality, but look at this. This is a great example of community-led leadership where the local village wants to become carbon neutral because they can see the impact of climate change. They can see that the glacial water supplies have been reducing. They can see that the local ecosystem is getting polluted. And so they want to transition to cleaner forms of energy as well. And this is the microgrid troubleshooting, that local chart that we put in so that the community can easily own, understand what needs to be done, what cannot be done, and how to maintain it. We've also partnered with the Indian government to power up the Indian democratic elections of 2019, where we were able to design small nanogrid systems, ship it to more than 200 locations, remote locations in helicopters, and our engineers went there to set up these grids to enable more than 3,000 people to be part of the Indian democratic elections of 2019. Now, once you have access to energy, the next step is to provide access to digital education via innovation centers that we are setting up. And these innovation centers are enabling these kids to access content like Khan Academy, Wikipedia, TED Talks. And now imagine these kids in these remote areas are now accessing videos on NASA on how to sort of recycle waste. And they are using all the learning tools as part of projects that they're doing and really engaging in experiential learning. And the whole idea is that we break the geographical mountain barriers that these kids face and then use technology that can really inspire and ignite the spirit of entrepreneurship and critical thinking in these kids. I now hand it over to Paris to take you through the rest of the technical presentation.
Yes, thank you, Jaideep. I'm trying to see how can I unmute myself, and that's always a problem. So, can you hear me well, Jaideep?
Yes, yes.
So, Jaideep spoke about the importance of trying to go to the remote areas and make it happen. And as Amarnath sir mentioned that we are all electrical engineers. At the end of the day, we have to make sure the technology is simple enough so that it's implemented as well as it is, you can say repaired and maintained well over the years in the community. At the same time, you need to evolve it in a way where, it also advances and advances for the benefit for the humanity. This is the latest wire charge controller, which we have, solar charge controller, which we've designed for areas which has no cellular connectivity and totally away from the mobile network, and it creates a wireless mesh network and then integrated with the LoRa technology so that the data can be seen on the nearest town which has cellular connectivity. The same setup, instead of data sharing, it can also help in voice communication and some kind of messaging between the villages. So it's inter-village communication as well as intra-village communication. This has been designed by ex-DRDO scientists, and this has taken us 7 years of understanding what is really required to design such a wire charge controller. And finally, it has come into light. And you see there's an app which is being designed. So in every village, there will be an entrepreneur who will be using this app to make sure that all the grids are maintaining without going to each and every house. So that's the kind of system we have set up. And we believe in I won't say we are with Edison and against Tesla or something like that, but DC microgrids is something we have been setting up, and we feel it's very simple than AC. There is a lot of limitations to DC also, mainly in transmission, but I think it is the most energy efficient solution which we can supply in these mountain areas as well as any remote areas of the earth. It's very safe, as Jaideep mentioned earlier, but also is very, very remarkable for electronics. So we're part of the IEEE DC microgrid standard, which will be coming up soon. And it's good to know that we are also able to use our field experience and mold the standard in a way where it suits everyone working on the ground. This year was very different for us. We are normally electrifying villages or setting up health education centers, but we got a very peculiar requirement from the field that can your solar power also, power up more of the health centers which have no instruments, and people want to get their vitals checked, and also there could be emergency cases for which we don't have facilities. So we took up a task of not only designing an off-grid solution, but also design DC-based medical equipments. If you see the next slide, which basically would help, remote medical centers, which come under the primary health centers in remote areas of Ladakh and even Northeast India, like Meghalaya, and have a holistic development of an area, not only on electrification but also on the health, because that may be the need of the hour. And this also helps in, because eventually you will have to, when the travel and tourism also comes here, they'll also need to feel safe when they are in these areas, that there are medical facilities available. So this is a new initiative which we started. And over the years working in Ladakh, for us, Make in Ladakh had become very crucial, because you can design as very good technologies and ship it to remote areas. But if it doesn't work, then everything becomes a plastic waste. So it's very important to make sure you skill the people in terms of deciding how they manufacture the electronics, but they also know how to set up the microgrids. So GHE cannot be everywhere, but we can always create micro entrepreneurs who can lead this initiative and assemble these systems there and there, so that for next time, if anything goes wrong, they don't have to call Bangalore or Delhi. It is made in Ladakh, it will be repaired in Ladakh, and it is sustainable in that area. And everything well and said, you can do as much technology, you can do as much of innovation, go onto the ground. But if it is not sustainable, self-sustainable, it will not work. Now, that led to us to creation of a livelihood initiative, which is very different from the technology, but we'll still integrate the technology into it, called the Mountain Homestays Program. The idea was all these villages which we have electrified have a rich culture and heritage to it. And when travelers want to come and reach these communities, they want to stay in the places where they can have good food, experience authentic culture, visit monasteries, and also, you see these beautiful homestays which we have designed. So all these villages which we have electrified, almost on 50 to 40% of the villages, we've actually gone ahead and selected few houses where we have set up homestays, which you can visit by going to booking.com or Airbnb or anywhere online in multiple portals and visit these places. With the money coming in these homestays, these people are now able to use that money to repair the microgrid if anything goes fault. So basically, energy access becomes as an enabler, but it becomes a carrot and stick story. If there is no homestay, there won't be any maintenance, as there won't be any income. So to create income, you have to set up homestays, which will actually aid the maintenance of the microgrids. And over the time, we have set up almost 55 homestays, and also we have restored very ancient heritage sites, mostly monasteries. And then we've also trained people on homestays. I mean, you can set up a homestay, but if you don't train them in well and how to serve guests, how to cook food, how to set up a bed sheet, it's very important to do that as well, because nice experience will only make the traveler come back again and again. And then on top of that, you can say my homestay is carbon neutral. It is powered by solar. It has solar water heater. I cook in the green. I cook vegetables coming from a greenhouse, and the water is from glaciers. I mean, what a lovely place to stay in. Of course, all these homestays have made some revenue. So this year, because of COVID time, it was important to wash your hands. So with the money these homestays villages made, they were able to reinvest that money into solar water heater so that they can get warm water, so that they could wash their hands and keep themselves clean. Because in these areas, the water is very, very cold. It's very difficult to take a bath and wash your hands every day. Secondly, it's also important to make sure that the water is not wasted. So with this kind of setup, it's actually aided the communities to make sure there are better facilities. And even when the travelers come in next year, these facilities will help the travelers as well. So it's become a good infrastructure upgrade. And, what about farming? At 14,000 feet above sea level, you don't get vegetables, but there are species and genetic innovations done by some of the organizations in agriculture, where now they can grow agriculture products in greenhouses, which you see here. It's very simple, but with the right soil, with the right plantings, you can actually set up these greenhouses. So most of the villages which have electrified, we've also aided in setting up the greenhouses. Now they can grow their own vegetables. So the idea was, in this COVID times, there wasn't any revenue coming in because there was no tourism. So once no revenue is coming in, there is no tourism, you can't buy food. So grow your own food and then have it. So this was the concept of setting up farm to stable strategy. And of course, as I said, technology cannot be removed from all these areas. If you go to these remote areas, the first question is, where am I? Which village is that? How old is this? Is there a monastery here? What is the culture behind it? To all your questions, we set up an offline Wikipedia for a village. We call it OVIS. It's an offline village information server, which in these remote areas, there is hardly any connectivity or no connectivity. But you go into the homestay, you have a Wi-Fi connection available. You log into that Wi-Fi connection, you download an app, and you get full information about the village without having to trouble the village homestay owner and asking questions again and again. So this way, you also get enriched by the knowledge of that area, which you will anyways appreciate it. And that will bring in more, enjoyment and a good experience in visiting those areas. So for us, women empowerment has been the forte because they stay in the villages. Men go out for work and for shepherds and farming and agriculture and other stuff. But women stay in the house. So we told, why not train the women on electrical engineering and also look at training them as homestay owners? Because if any guest comes, they are the one who's going to host them. And if anything goes wrong, they are the ones who could kind of, make sure they can repair those places. So both electrical engineering and homestay training has been given to the women. We didn't end there. We were wondering what else can we do with the electrified villages. It's contrary that Astro Stays is an initiative. Sorry? Okay. So Astro Stays is an initiative which is basically combining astronomy and homestays of GHE. So now you may be wondering, you're electrifying villages, then how can you use dark skies? But that's the concept, right? We don't create light pollution when we electrify villages. The idea is to create livelihood. So AstroStay is another way of promoting astrotourism in Ladakh. So if anyone has gone to Ladakh, if you've seen the blue colored lovely lake, on other side now you have China people coming in now, which is fine. They too can enjoy the lake if they want to. But even we have our homestays on that lake, and you get this beautiful sky because we have trained 35 people in Ladakh from 15 different remote villages on how to actually use a telescope and give that experience of planetary science and astronomy and stargazing to the travelers and the tourists coming to those villages and staying in their homestays. And this is how it looks like. You enjoy the night skies, understand the planets Jupiter, Saturn in the most clearest skies of the world. Himalayas have the best skies in the world, and in the night you get such a lovely homestay to sleep in and then enjoy, and then get up in the morning and then do your trekking and whatever enjoyment you want to do. The people who lead these are called astropreneurs, and these are the sessions in the night where travelers, monasteries, monks, young kids, even all kinds of locals, they want to see, because cosmology and Buddhism are related to each other. So in these mountain areas in Himalayas, there's a lot of concept of Asian folk tales of astronomy, and these telescopes are
Excuse me,
powered
sir.
nothing but yes.
Sir, we are actually tight on schedule. It would be great if we could wind up as soon as possible.
In the next 1 minute.
Yes, sir. Thank you, sir.
Awesome. So these are the telescopes which are powered by solar power. And so if you can, Jaideep, skip over the slides. And these are our astropreneurs who are using these telescopes. So again, energy access to power up astronomy. And then we go further where it comes to you, Jaideep. Thank you.
Thank you, Paris. And so ultimately at GHE, our vision is to create villages that are smart and sustainable, and which can really fuel the growth in these areas through technology as a means to development. We have been, this is a snapshot of the impact. It's across the spectrum from the lives that we impact to the carbon that we offset to the micro enterprises and to the students and the women that we have really taken along this journey of impact. Our belief is that the indigenous populations that are living in the remote areas, they face a lack of development due to the various constraints that they face. But there are opportunities for sustainable development, because where there is a lack of opportunity, there is always a scope to bring in more innovative approaches and bring in development. For our work in the holistic development and for our work on climate action, we have been recognized by the United Nations by the 2020 Global Climate Action Award. And this is a huge recognition for what we have been doing at GHE. And we really thank the United Nations for recognizing the work that we are doing on the ground. We have also been recognized by the G20 nations, by the World Travel and Tourism Council and the World Tourism Awards. And our work has been featured in National Geographic, the World Economic Forum, and the BBC. You can actually go on Amazon Prime and look up this National Geographic documentary, which is called Breakthrough: Power to the People. We have also now been collaborating with the European Space Agency, where we are looking at space applications and their way of sort of creating local level surveys, monitoring the grids, and also looking at terrains to identify more areas that are still living without access to energy. And so we are really excited about this collaboration that we have done with the European Space Agency in leveraging space technology for bringing in access to clean energy. Our future tech revolves around creating natural resource monitoring systems, because as the Himalayan communities continue to face the brunt of climate change, we are looking at sensor-based monitoring of natural resources to, in a way, provide carrying capacity of the Himalayan communities for travelers, so that there is not overconsumption and depletion of the natural resources. And so we are using technology as also the same technology will be used to monitor the health of the people. So this is something really interesting that we are working on. And if you are interested, please feel free to reach out to us, and we'll be happy to share more details on the pilot that we are doing. And we are looking now at expanding to different corners of the world, whether it's Sumatra in Indonesia, to Madagascar and Namibia in Africa, and Nepal. So these are communities that we are sort of targeting as part of our expansion and growth plans in the coming future. Thank you so much, everyone, for being so patient and for hopefully taking off, some inspiration in terms of what technology can really do to bring in development. We can be reached at our email IDs that are on the screen. and would be great if we can create some partnerships and foster some collaboration coming out of this conference. Thank you so much, everyone.
Thank you, sirs, for the wonderful address. I now call upon Dr. Sabina BVK, who is an assistant professor in the Department of Electronics and Electrical Engineering at TKM College of Engineering, to deliver the vote of thanks. Over to you, ma'am.
Yeah. Good morning, one and all. Am I audible?
Yes.
Yes, ma'am, you're audible.
Okay. Yeah, it's my privilege to offer a vote of thanks on this occasion. On behalf of all organizers from RAICS 2020, I am expressing our sincere gratitude to our most valued speakers, Paras Lumba sir and Jagdeep Bensal sir, for sharing their enchanting experiences and projects. It's once again reminded on humanitarian side of technology. They are trying to merge technology with tourism to create sustainable solutions. We are all inspired by your great projects. Thank you, sir. Our sincere thanks to Honorable Amarnath sir for his great support and motivation. Thanks to all delegates from IEEE Kerala Section. Thanks to all participants who are currently viewing online and all volunteers. Wish you all good day. Thank you.
Thank you, ma'am. We at IEEE Kerala Section would now like to present Mr. Paras Lumba, who is the founder of Global Himalayan Expedition, with a memento as a token of gratitude. Thank you so much, sir. Next, we would like to present Mr. Jaydeep Bansal, who is the Chief Operating Officer of Global Himalayan Expedition, with a memento as a token of gratitude.
Thank you.
I would like to express my heartfelt gratitude towards everyone who has joined us here today. I would also like to thank all the enthusiastic team of IEEE volunteers for their constant efforts, and all the honorable dignitaries who have graced this occasion with their presence. Thank you for your support for our shared mission to advance technology for humanity. And with this, we mark the end of the third keynote session of IEEE RAICS 2020. We shall be beginning the second set of paper presentations of IEEE RAICS 2020 shortly. So I request all the registered participants to join the same using the corresponding Zoom link. Thank you once again.